is where we begin. Topic 16. Somebody write this down so we're sure to know where we started. All right, incident command system of, okay, the major California wildfires, like they ever have a fire there, huh? These are some of the places where it began from what I'm imagining here. Multi-agencies working to go together, coordination and cooperation over everything, and poor overall order in what it does. We're going to get into this. I have a piece that is not being shown at the bottom of the screen. And okay, maybe that'll do it. National Incident Command Center Management System, NIMS, National Incident Management System, is a systematic, proactive approach with guide departments, agencies at all levels of the government. It's a non-government, also with the non-government and private sectors. I'll get my head together here in a second. Anyway, the Regional National Response Framework, the NRF, these are some of the ones. Oh, God, it did it again. There we go. NIMS provides a template, NRF provides a structure and mechanisms, and ICS, the Incident Command System, provides accountability for all of it. What is the Incident Command System, ICS? It's a management tool designed to bring multiple, including those from different jurisdictions, together under a single overall command structure. That's as simple as it gets. That's really what it is. Everybody works together. When you, and I'm assuming all of you have some of the ICS training, and that's what the whole thing is. It was designed to be the beginning and actually to keep everybody organized. That's how it works. Based upon simple and proven business management principles, managers and leaders perform the basic daily task of the planning and directing and organizing and coordinating and communicating and delegating and evaluating, just like in a business. The functional areas. Now here's an issue. Performed under the overall direction of a single incident commander in a coordinated manner, even with multiple agencies across the jurisdictional lines. That's how it works. Now, can you guys see that tree? Because where everything's pointed here, it's very difficult. Unless I move it. Here we go. I'll do it this way. All right. Under the Incident Command Center, you have public information, liaison, security, and safety. And under they're all subdivisions, and directly under is finance, logistics, operations, and planning. That's how it's basically laid out. It's fixed and unchangeable. It is not fixed and unchangeable. That means during the whole system, as you're working an emergency or whatever, it can change. It is not a means to take control or authority. You're working for somebody else. It's a way. It is not a way to subvert the normal chain of command. It is not always managed by the fire department or the first agent to arrive on the scene. It can change. It is not too big and cumbersome to be used in small everyday events. And it is not restricted by government agencies and departments. And I just got to notice my internet connection is less. I don't know if you guys see and everything here. It has, the ICS structure has two interrelated parts, the management by objectives. And under that, you understand the policies, procedures, and statutes that affect the official response. That's your objectives that you need to have here. You need to establish incident objectives. You need to select appropriate strategies for the cooperation and resource utilization. And you have to apply tactics to most likely to accomplish the objectives that you want. And the next part is the organizational structure. It's a flexible organizational structure that can be modified to meet the changing conditions. You'll always have things changing as you go on. And this is structured to change as appropriately as needed. One person in charge is the incident commander, the IC. The General Staff Information Safety Liaison Officers are the general staff, and the four major operating sections are planning, operation, logistics, finance, and administration. Some of these are pretty self-explanatory what they do, so as you go along. Some people have trouble with the word logistics, but it's just what makes it all work. And here you see a breakdown of what is under the incident commander. The public information officer, that's the person that talks to the public. You don't, as an operator. If somebody comes up to you and, hey, I'm from XYZ radio station and I want to get your opinion on it. No, go talk to the information officer. That's one of the key points. Never get in the middle of it. Safety officer, liaison officer, to report directly to the incident command center. And under each of those is, I won't go through them all, but you can see the branches and what is happening under each of those sections and who is in it. The incident commander, initial IC, is usually the most senior on-scene officer from the first responding agency. Doesn't mean the oldest guy, it means one of the most experienced. They're the management of the incident. They take charge and control it. And they're setting initial incident objectives. They decide what has to be done first, and they implement an incident plan. And how does an MCOM group fit in? Involvement in any incident where the ICS is used by invitation only. You have to be asked to come in. There is no role for the off-street volunteers. Off-the-street volunteers, hey, I got a ham license, I can come in and help. You have to have training, and you have to have proof of that. And they will call you to be part of it. Relationship of an MCOM group to the ICS structure will vary with the specific situation. And our income, ARES races and so on, and we have ARES races and Skywarn included in our group of what we do. They may have a representative on the logistics section or the communications task force. And that means one of us could be assigned any of that. Logistics section orientation, logistics chief, these are the people that are directly under them. Transportation task force leader, communications task force leader, medical support task force leader, personnel resources task force leader, and the most important, food. And then under those are some other additionals. Any comments before we go on? What does ICS stand for? Of course, it's an International Correspondence School. No, it's the Incident Command Center. What is ICS? It is, the first one, a management tool for coordinating the resources of several agencies within a single command structure. The ICS has two interrelated parts. What are they? They are management by objectives and organizational structure. And aside from the incident command, there are four other major operating sections. Which are they? They are planning, operations, logistics, and finance administration. What is the MCOMS group's relationship to the ICS structure during an incident? Very simply, the first one. The MCOM group always serves within the logistics area, getting things where they need to be. Now let's see if I remember from the last one. There it is. It's going to make me go through this every time.
No.
So where were we? 16, right? 17 now. You can actually see it a lot better, I think. I could just go through them this way. All right, slideshow. All right, preparing for deployment. Was there a question that I missed out there? I apparently cannot see the waiting room again, even though I was sure I would be able to the way I have it set up. So, don't know. I want to make sure before we go on that there's nobody out there waiting. Apparently not. Doesn't say that. All right. Prepared for what? You never know what challenges or an emergency situation. It's true. There's a wide range of considerations, including your radio equipment, power sources, clothing and personal gear, food and water, information, and specialized training. Well, through this, we're supposed to learn how to know what to wear for the generator.
You might be okay, but you're pretty low.
Who are you talking to, Dave?
Your iPhone.
There we go. Now, the tube deployments, no two deployments are the same. That's very true. Each region offers its own specific challenges. What is appropriate for rural Minnesota in January won't be for work for urban Southern California in any season. That's very true. And your areas around here are very unique as well. The goal is to help you think about ways to prepare for your particular situation in this. Jump kits, very important. What goes into a jump kit and all of that is very important. And because here it is, a scenario, it's 3 a.m., where's everything that I need? Keep a kit of the items you need ready to go at a moment's notice. It's called a jump kit or a go bag. And with that, you're going to have some of your medications, maybe if you take them. It's going to have change of clothing and all that. Without a jump kit, you will leave something important at home or bring items that you don't need. They won't work for what you're doing. Gathering and packing your equipment at the last moment wastes a lot of precious time. And think enough, what's that? Think through each probable deployment ahead of time and a range of situations that might occur. Questions to ask. Which networks will you need to join? Which equipment will you need to do so? In other words, networks. What do you need to join and what do you need? HF, VHF, UHF, what are you going to need? You will need to be able to relocate quickly or can bring a ton of gear. What are you going to need? You have to know that ahead of time. Will you be on foot or near your vehicle? Each presents its own little challenges. Is your assignment at a fixed location or will you be mobile? And how long will you be deployed? Up to less than 48 hours, 72 hours, or a week or more? That's something you don't know. Will you be in a building with reliable power and working toilets or a tent far from civilization? What sort of weather or other conditions might be encountered? Tells you what to bring, what to wear. Will there be food and water in some form or sanitary facilities available? And if you're like me and have a weird diet that you can and cannot eat, make sure you bring your own stuff. And will there be a place to sleep? Do you need a plan for a wide variety of possible scenarios, or only a few? And that one's hidden. again, there's something awry with the display. I don't know what the last one was. Divide your jump kits into two categories. You have a couple of jump kits you can grab and go. One for under 24 hours, one up to 72 hours. Everyone has their own favorite list of items to keep in a jump kit as well. Jump kits can be a duffel bag. They can be a backpack. They can be anything in between. Something to put it in. One or more backpacks, suitcases, plastic storage tubs, and all that. Package individual items of Ziploc bags or plastic kitchen containers. Really important when you're trying to find stuff. I utilize that in a whole lot of ways, even not into this. It's become my way of keeping audio connections and all that separate where I need them in my job. Radios and accessories, handheld VHF or a dual band radio. Some people also like to bring a spare. You may want to consider that. With the advent of all the cheap radios that are on the market now, that's not a difficult thing. Spare and rechargeable batteries are for the handhelds are good. And an alkaline battery pack, I would recommend that highly to get them for your handhelds if you do not have them already. And a pack of alkaline batteries, because if you're not anywhere you can charge them, you can always pull out a pack of batteries and get back on the air. Speaker mic and earphone for handhelds really works, because if you're in a noisy environment, you're going to be struggling to hear what's going on. Otherwise, you got to have something in your ear. And battery chargers, AC and DC for the handhelds. There are battery chargers that plug into your car to keep your handhelds on. Jump kit ideas, let's continue here. Radios and accessories, mobile VHF dual band radios, HF radio, multi-band HF antenna, tuner, heavy parachute cord, and nylon mason's twine. That's, by the way, that parachute cable locally here at a place called Coleman's in Millersburg. Really good prices in that. Buy it 1,000-foot roll at a time. Multi-band HF antenna tuner, although we covered that. Mason's twine. UHF, VHF gain antennas and adapters. Roll-up J-poles are great to have. You can find how to make them just about anywhere online. It's not a bad idea. You make them out of ladder line or even old TV twin lead, which you can still buy at most hardware stores. Makes great J-poles. Coaxial feed lines, ground rod pipes, and all that sort of thing to ground your radios. If you're an HF, you definitely need that. AC power supplies for UHF, VHF, mobile HF radios, accessories. Large battery or source for VHF, UHF, mobile, and HF radios with a charger. One of the coolest things that came out now are those jump packs. I've been using jump packs with the lead acid batteries to power PA systems remotely. And now they have them with lithium ion, I believe is in them. Long time power, low weight on them as well. All related power, data, audio, and RF cables and adapters that you're always going to need if you're using digital. Make sure you have spare cables for all of that. Small repair kit, hand tools, multimeter, connectors, adapters, fuses, key parts for everything. And this sounds like it's crazy to have all this stuff, but there's some of the reasons for some of the things in your books that I'm supposed to be checking off is because in the past people have showed up at some of these places, didn't know how to put a connector on, or even how to operate the tools that were necessary, soldering irons and so forth. So that's important that you know how to build all this stuff. But you need all the parts in your jump kit to be able to let you do that too. Materials for improvisation, wire, connectors, small parts, insulators, duct tape, insulators and things like that. Make a trip to your local Tractor Supply. They've got all kind of stuff to make electric fence that makes great antennas. Photocopies of manuals for equipment. This all sounds like overkill, but believe me, it's not. Headphones, definitely you need them for your privacy. You can't hear when everybody else is around you making noise. Proper connectors and adapters to fit just about anything. You'll find old radios use 1/4 inch, new ones use 1/8 inch. You need little adapters for everything. Specialized gear for packet, ATV, or other modes. Multiband scanner is a good thing with the radio, weather radio in it. Your personal cell phone, they don't do pagers so much anymore, spare batteries and all that. Pencils, legal pads, pencil sharpener. And it sounds like a strange list, and it goes on. But it's important. Clothing for the season that you're going to be in and for the length of deployment. And your toilet kit, soap, razor, deodorant, comb, all that sort of thing. Foul weather or protective gear, warm coats, hats, and so on as needed. A sleeping bag, closed cell foam pad, pillows, earplugs, if you have trouble sleeping around with all the noise going on. High energy snacks, candy bars. No, not candy bars. Something a little better than that. Easily prepared dried foods that will store for long periods. Eating and cooking equipment that needed, and water containers filled before departure. First aid kit, personal medications, and prescriptions for up to 1 week. And money, including large quantity of quarters for vending machines and tolls. That's not even a joke. You need to be able to operate your vending machines. Telephone calling cards, I don't see them so much anymore. That shows that this is a little bit dated, but so be it. Your contact information, your ID cards and other authorizations. Nowadays, there are a lot of ways to take along your ICS certificates and certificates for this particular course or any other certificates and licensing that you have. You can have them stored in one of your, I don't know, everybody who uses Google Mail has a cloud storage service, and I'm sure others do too. It doesn't hurt to keep them all in a folder on your cloud service. Then you can bring up that folder and have everything at your disposal right there. Mine are always on there. And it's handy because you lose the paper ones. You don't want to take them out. They come home and framed. So you got to have that. Frequency lists and net schedules for everywhere you're going to be. Copy your amateur license, maps, both street and topographical. And the topographical ones really are a kind of a nice thing to have when you're working in the mountains. It really is. Key phone numbers, email, internet addresses, and so forth. Are you getting a feeling that this kit is going to be pretty darn big? Operating supplies, message forms, print out a bunch of them before you go. Standard message forms used by the agency you're going to be working with, legal or size notepads, log sheets or log books, whatever you need, sticky notes, all of that sort of thing. For quick deployment kit, this is another kit that's just for quick stuff. Handheld radio kit, personal essentials in a large day pack.
Yeah, this is a training session.
Hi, Dave, you're back. And accessory toolkits, emergency power kits, short and long-term personal kits and duffel bags. Again, duffel bags, Coleman surplus, Millersburg. It's worth the drive there. Field kitchen and food box and plastic storage tubs. You can get them anywhere. Field shelter kits is tents, tarps, tables, chairs, battery, gas lights, and now, of course, the LED lighting, which is a little bit safer. Plastic storage tubs, and I would add to that, get some kind of a small solar charger too. Pre-planning, you got to know where you're going to go, what to do. What frequency should you check on initially? Is there a backup frequency? You got to know those before you end up where you're going to go. Get all this stuff together beforehand. If a repeater's out of service, which simplex frequency you're going to use? That's all in the pre-planning. What nets will be activated first? Should you report to a predetermined location, or will your assignment be made as needed? You need to know that. And familiarize yourself with the resources, requirements, and limitations of possible deployment locations. And that's some of the things you're going to need to do on your own to find where you're going to go before you end up. They'll tell you, we're going to Puerto Rico. Oh, cool, warm. Well, no, you're going to be there working, but you get to look online to find out what you're going in for, and you can do a little more of getting the right things. Well, you need a long antenna cable to get from your operating position to the roof. Maybe you can find that out. Are antennas or cables permanently installed, or will you need to bring your own? Will you be in one room with every separate room? Is there dependable emergency power to circuits at possible operating positions? Some of this stuff, even though you're pre-planning it and you end up at a location, you have to do some quick thinking. Does the building have an independent or dependable water supply? Is there good cell phone or beeper coverage in the building? Can you reach your local repeaters reliably with only a rubber duck antenna, or are you going to need a bigger antenna for them? And that's something that I recommend everybody who has an HT, don't rely on that rubber duck. I had a couple laying around here. They're longer, better antennas. Diamond makes a good one, and a few other companies do too. It gives you really a better chance of hitting a repeater than it does on a rubber duck. Rubber ducks are not good antennas. They're a compromise. They're made to be portable so you don't break them. But when you really want to use it, you're going to need a little better antenna. If the repeaters are out of service, how far can you reach on a simplex channel? That's why we are working on planning with some simplex nets to show you how to use your simplex nets. You're going to be relaying messages because you sometimes can't work on a simplex channel. But if the repeaters go out of service, you need to know already how to do that. And we need an HF radio to reach the net. Depends on what you're doing. And consider escape routes. If you could be in the path of a storm surge or other dangerous conditions, know all the possible routes to get out of that area. Storm surges, they cover you with water and can kill you. You need to know how to get it out of where you are. If you will be stationed in a large building such as a school or a hospital, find the fire exits, very important, and learn which parking areas will be the safest for your vehicle. Think about, in regards to that, the fires that are going on in California right now. And as people look at this in the future, they'll be talking about fires in California too, but they can come up very quickly. Santa Ana winds just kick in and they go everywhere. The more you know, the more effective and valuable you will be. That's why the training and education is important. Work within your own MCOM organization to get any additional training and information you might need. American Red Cross offers self-study or classroom courses that either directly involve or depend on effective communications. FEMA, Federal Emergency Management Agencies, Emergency Management Institute, so forth. Participate in any of the drills or exercise offered by the ARRLs, like the ARRL's field day and simulated nets, emergency nets, in our place, parades, races, anything else that we get together and help in our own community. And what do you need at each level? And your home, neighboring community, there's where we are, city, county, state. These are the ones we're going to be working in most. Most of us won't be traveling to other areas, although we often get an email from the ARRL saying we need operators here, there, or anywhere. Any comments from anybody before we go on? That was a whole lot of equipment lists and things to think about in this one. Of the following, which is the best reason for preparing a jump kit? Well, it's really simple. You will not leave something important at home or waste valuable time. And we think about that. How many times have you had to leave real quick and go somewhere and you get there and realize, I forgot a whole bunch of stuff I need. So this is why you do it, plan ahead. Which of the following would you admit from a jump kit prepared for a 12-hour deployment? Oh, I couldn't find a button there. The camp cot in the tent. You probably would not need that. And which of the following are the most important items of information to include in your jump kit? Your ID cards and other authorizations are very important. Among the following, which is the least important item of personal gear to include in your jump kit? That's an easy one. A deck of playing cards. But you need the frequency list, schedules, contact information of other members of your group, and so forth, and key phone numbers and emails, internet. That was already covered in there. If you are assigned in advance to a particular location for MCOM operations, what is the least important thing to know in advance? Least important is the regular business hours maintained at the facility, because you're going to be there no matter what. You do need to know the escape routes, the availability of radio equipment in the facility, and the location of your operating position and the planned location of the antennas. Very important to know. Now we move on to number 18. Now, all right. Let's go ahead. Equipment choices. All right. There's no one best set of equipment that will ensure success for every assignment. You hear everybody saying what's the best. Well, it depends what you're needing. When deployed for PS or emergencies, expect January 3rd. Expected outer garment, standardized look for ARES, easily recognized ID requirement of NIMS, waivers granted by the section. These are things you'll need. Professionalism is key all the time. These things right here, you get them at the ARRL. They're great. I ordered one. I got a certificate, a gift certificate for my birthday. I ordered one. Came in the wrong size. They took care of it. But you can always go to Walmart and get them, but they don't say amateur radio communications and they don't have the ARRL logo on the front. They come in different things. You can get the ANSI ones, which are the breakaways. You can get the vests. All different. They're available. These are all available at the ARRL. Some of these even have pockets and stuff to put your radios in. There's one that works great on a motorcycle. Well, you can tell this is dated why they put this together, but those are the ones they call that safety green. I call it a color that messes up my eyes. silver reflective tape on it, logo on the front and back, and you can put your ID badge in it. Oh, wait a minute. I am running out of power on this computer. I forgot one important thing. It's going to shut down on me if I don't fix this real quick.
Get the spare battery out of your jump kit.
Oh, it's on the floor here. I was moving computers around and forgot to plug this one in. Pardon me while I'm down here. There we go. It's a Dell, dude. All right. Oh, and you can add your, you can have all the other, your group's letters put on them. And I have a guy who does mine for me. I'm gonna have him label mine too. Transceivers. In your 2 meter 440, 35 to 50 watts is a great range to be in. Get something that's rugged and reliable and can operate at reasonably high duty cycles. An external cooling fan if the one's not built in. I had one here to show you, but these little covers made in China, the bag. It's that guy. They're little. They're the size of your palm of your hand. They're about 40 watts or so. Little fan on the back keeps them cool. And you can program them with or without the computer. This one, there's a QIT, and they come in many different brands, but it's always the same radio. And it's just a tiny thing. I have a couple of them that for several of the vans that I have. If I'm jumping in a van, I want to have radio there. So I have a couple of them. They can operate at reasonably high duty cycles. These will run quite a while. An external cooling fan if one's not available. Handheld transceivers are only used when extreme portability is needed, shadowing and official and so forth. Otherwise, you're always going to be using a mobile radio. When everybody thinks I'm going to get an HT, a handheld radio, they're not the best. And incidentally, new hams coming in, that's first thing they want to buy is a handheld radio. They should be buying something a little more powerful because those rubber ducks, which are an attenuator to begin with, and a walkie-talkie, it doesn't cut it. Handheld retriever, extreme portability is needed, shadowing and official, adequate battery or other DC power supply is not available. They run out of power. They can overheat and fail. They should not be relied on to operate in a high duty cycle at maximum power because of that failure. And there they show a Yaesu 8800 on the top one. I have one of them in the car. And they're kind of cool because they have some features that are designed just for emergency communications. The crossband repeater and so forth is in them. And that old HT there, that's an Alinco. Transceivers, well, there's somebody at one end of the room. Transceivers for HF, having both AC and DC power capability is a great thing. 12 volts, HF radios are 100 watts, and some of them are QRP, 5 watts or less. And again, a lot of new hams say QRP is the way to go. And then they wonder why they can't make contacts, because 5 watts isn't going to get you a lot of contacts. It's going to be a challenge to you. And if you're up for a challenge where you can try till you're blue in the face and finally get a contact, that's okay. The QRP stuff is great for digital communications because you don't need a whole lot of power for that. But if you're doing this for HF for MCOM, use it appropriately. 100-watt variable output radio should be used, and everything is a 100-watt radio, you can dial it back to just about the lowest power you want. Unless power consumption is extremely important, they overcome noise at the receiving station by using a higher power and turning it down to conserve the battery power when necessary. You can turn the power down on any radio. Some will go lower than others, but it's just the way they're designed. So there are some things in a QRP radio that is missing, like lighting and so forth. And again, on a lot of radios, you can dim the lights, so you can have some of the best of both. And do not use DC to AC inverters to power HF radios. That's a waste of energy to do that. If you have a radio that already works on 12 volts, you're far ahead of it. ICOM 706 Mark II-G right there. I'm down to one. I had a couple. I sold them. Great radios. They'll dial back in power. They do consume a little bit more. There's three versions of the 706. Get the Mark II-G. The rest of them consumed a little more power. And that's become my mobile radio forever. I've had one about 20 years now. Voltage tolerance 12 volts DC, 13.0 to 13.8 is typical. Some of them will work on 11, but not so many. You lose a lot of, like a 706 will shut off if the voltage is too low to protect it. And there's voltage tolerances that some of them, you have to read the specs on them when you're buying them to find something that'll work. And again, they show the 706. And the receiver performance and sensitivity is the ability to receive weak signals. The sensitivity is important. If you're working out in a field or anywhere, even at home, you want to be able to hear that stuff. And if I could turn the camera around, I have a wall here of radios, old and new. I have an ICOM here with a solid state amp. I have a Kenwood with tubes in the finals. And I have a Heathkit up there with all tubes. Each one has their different approach to weak signals. Some of the old ones don't discount them. They really work well. Selectivity, the ability to reject signals on adjacent frequencies. On HF, you're supposed to be able to work 3 kilohertz apart. And a lot of these times, you have some radios that can't quite do that. Others do it really well. Again, just a matter of the way they're made. It helps to know have someone help you to buy them. Intermodulation rejection is the ability to prevent an undesired signal from mixing within the receiver and causing interference. We often call them birdies. They show up and there's noises that you'll hear as you tune across a dial. That's made within the radio. You want to have intermodulation rejection. It's made because it's receiving a signal and mixing with something in the radio most of the time. It's important when operating near public service and business radio transmitters to have that. And I don't know if you've noticed it on your Chinese-made radios, very often you'll be driving down a road, squelch will open, and you hear pager tones. That's what I'm talking about. Some of them, like the ICOM 8800, great radio, 75 watts that you can use, or is it an 8,000? Maybe it's 8,000, 75 watt mobile radio. However, that receiver is so wide, it picks up a lot of intermodulation distortion, or IMD. Receive filters are important for HF operation. That narrows the received area down quite a bit. And choose appropriate filters for the type of operations you're most likely to use. There's different bandwidths of these receive filters. What they do is narrow the area that you're hearing, that you can receive. CW is a narrow, very narrow. RIDI is narrow. Phone is about a 2,500 hertz bandwidth on those. So if somebody is 3 kilohertz away, chances of hearing them, pretty slim. Digital signal processing, DSP, is popular and has evolved quite a bit in the past 20 years from when I first was introduced to it. The newer radios are incredible. They can, with digital signal processing and digital audio processing, you can clean up a signal really well. You can allow clear reception of signals that you might not otherwise be able to get, and heavy interference. Noise blankers, they reduce impulse noises like In vehicles, you got your spark plug noise, and it's an impulse that just has a rhythm to it. It can be power lines arcing, it can be generator ignition systems and various other things. But a noise blanker works only on impulse noise, and it can do it quite well. VHF and UHF antennas, a good antenna mounted as high as possible is more important than a high-powered transmitter. And let me say it again, a good antenna is better than more power. And that goes for anything. It provides, in a VHF and UHF, however, it provides gain to both the transmitter and the receiver. The higher the gain, the antenna may also allow output power to be reduced, prolonging your battery life. You'll see a lot of just many different kinds of antennas, but if you look for something really high gain, it helps a lot. I have two vehicles. On most of the vehicles, I have a quarter wave antenna because it's small. My vans, some of them will hit things. And I have small antennas. Others, I have big ones on lower size vans, and with a lot of gain, they work well. Flat terrain, well, use a mass mounted single or dual band antenna with at least 3 dB gain on flat terrain. And in my flat terrain, to me, well, south of Peters Mountain, there's a lot of area wide open without mountains in the way. You get north of Blue Mountain, you start running into mountains that get higher as you go up north. If you're in Florida, you really got some flat terrain to work with. And operating in a valley, this is what's interesting. A low or unity gain antenna, like a quarter wave, has a flatter radiation lobes, unity gain J-poles, and gain antennas of low angle radiation. Now, we experimented with this back, I don't know, 30 years ago, some friends of mine and I, we did with unity gain antennas on our vehicles, and in the valleys, and we're trying to get over the mountains, they worked a whole lot better. A directional 2-meter antenna beam 3 or 4 element Yagi. I have an 11 element here somewhere that I want to put up. Collinear antennas, they make a collinear antenna for 2 meters that stands 8 feet long. And you put that on your car, it's kind of funny looking, like all of my antennas are. It really works well. The Station Master series of commercial open dipole antennas is great. The Station Master series of collinears is great. And commercial made open dipole arrays, we had them on our repeaters, on our local repeaters a lot. And I think a lot of them have gone over to the Station Master series now. And that's kind of what we're going to here very shortly on our 7.6 repeater. Magnetic mount antennas, when you're operating in someone else's vehicle, it can also be used indoors. You can stick them on any steel surface. I know a guy has one stuck to his refrigerator that works well for him. We used to always stick them on the filing cabinets. Well, I did. In the jobs I had, I always had a 2-meter radio handheld or something with a antenna stuck on a filing cabinet. The boss didn't care, he didn't know what it was. Beams or ductwork, or even you can stick them anywhere, even upside down, they work. Rubber duckies, like I said earlier, have a negative gain. Use at least a quarter wave flexible antenna on your HTs, your walkie-talkies, whatever you want to call them. Or a telescoping 5/8 wave antenna is a great one to have. I used to have one of them stuck in here somewhere too. They're great. They're telescoping they're made so usually when you drop them to collapse them, it's still like a quarter wave maybe at that point. And again, at a ham fest coming to you soon, you might be able to find some of these. UHF, VHF antennas, magnetic mount mobiles. Looks like we covered this one. Why did it come back to it? But I guess it's just showing us pictures of what they look like. Roll-up J-poles. Like I said, you can make them a 300 ohm television twin lead. They can be tacked on a wall, hoisted into a tree with a heavy duty string, anything like that. You'll find directions to make these everywhere. They're just a very popular antenna. They have a couple notches cut out, as you can see at the bottom. That's where you hook up your RG58, 50 ohm lead in there. And there's a quarter wave cutout, a quarter-inch cutout, about a quarter wave up. And you'll find these, like I said, everywhere. They tell you how to make them. It's made from 300 ohm twin lead. The wires are shorted together at the bottom, but are not shorted together at the top. You can make a hole in the top for hanging them up, and I've seen them strung over a tree or hang them up anywhere, and they work. And the RG58 can be any length because that's a resonant antenna. It won't matter. HF antennas, no single antenna for HF operation. No, there's nothing perfect in HF, believe me. And it depends on the size and terrain of your area that you need to cover. Conditions under which you must install and use it, also it depends on that. Near vertical incident skywave antenna, NVIS. That was the buzzword a few years ago, and a lot of people think that was a special antenna you had to buy. You can make them. I have one out here on 75 meters in my backyard. It's NVIS because of where it's how high it is off the ground. For local operations up to a few hundred miles, they work great. It's a random wire or a dipole. These are different kind of antennas. A dipole at less than a quarter wavelength above the ground. The signal is reflected almost straight up and bounces off the ionosphere and directly back down. On 75 meters, you take 120 feet of wire that you get at Home Depot, cut it in the middle, feed it with a RG8 or some 50 ohm cable, put a little 6 coil wrap, wrap your Feedline in 6-inch coil, 6 turns, tape it with electrical tape at the feed point. You have an antenna that'll work pretty much all of the 75 meter phone band. And its signal, they mount that less than a quarter wave off the ground. You're going to cover 75 meters in an area quite well over the whole state and beyond because it bounces off the atmosphere, the ionosphere. And it's the best thing to use in 40 meters during the day and 80 around sunset. They work great. I use one to check into the ARES races net, ARES net, I guess it is, on Sunday morning at 8:30 here in Dauphin County, Pennsylvania. That's when that's on. It's on 3993.5. And this shows an NVIS used in the Army. They strung it up to a tree, antenna support cord, which available at your local Coleman's junkyard. We used to call it Army surplus. It has a counterpoise 90 degrees apart for a counterpoise that has in the back of it. And that's, why not? Hikers use it. It was developed in the military. Now here's another one on, that picture didn't show up. It's supposed to be, there we go. The military is great for this. They have that big antenna that you see on the back of the Jeeps, and it's mounted at the bumper. It's held up and then tied off in the back. It's I haven't tried that on my car yet. I'm gonna have to look into that. Another NVIS is a center point up in the air, and you're coming down at a inverted V. We kind of use that on field day with when we use our trailer. We use the trailer as a center point, put a pole up, run the wheel over it, and hold that center point up and feed it in the center. And then in the other ones, you show different versions of that for different bands and so forth. For emergency communications, near vertical incident antennas are great. If you're going for DX, not so much, but in emergency situations, you don't want to go for DX. You want to go what's around you. For most portable antenna wires, you're going to need a tuner, especially for the NVIS stuff. And again, I don't like tuners, so I pre-plan. I cut all my stuff to be resonant. But the thing that's going to happen, because of the different areas you are in the terrain and so forth, you're going to have to tweak it in a little bit, and an antenna tuner will do that. The antenna impedance varies with the height above the ground and proximity to nearby objects, and that's why it changes. And when you're quickly putting them up, that could be a problem. Also include a ground rod, clamps, and cable in your kit, since almost all radios and tuners require proper ground in order to work. Very important. And there's a picture of the MFJ antenna tuner display. Communications beyond 200 miles, commercial trap verticals work. There's no ability to reject interfering stations from other directions because you can't maneuver it. But a directional beam antenna will. Its best performance for wide areas on 10 and 20 meters. Anything lower in frequency than 20 meters, they become unmanageable in largeness. I have a 40-meter beam. It's bigger than my house. It's not up right now. And with a beam, you can maximize the desired signals and reduce interference from the stations in other directions. They're expensive, large, and difficult to store and transport. And of course, they usually sit on a tower. And the verticals, there are a lot of verticals. We use them on field day. Usually, we set up an emergency vertical. Real easy to do. It looks a lot. As I look close at this, pretty much like what that vertical looks like, a coil at the bottom, tapped, and a vertical element to it. An HF beam, they have a driven element, and the rest are directors that head out, in this case to the right. And that's the direction of the beam. This is a Yagi, as developed by a Japanese gentleman, rather. And the reflector in the back, it acts as a mirror and reflects it. Coax feed on the second one. It's your driven element, and the rest are directors. This is a modeling program that shows what this looks like in RF terms, with the signal pouring out the front and not out the back. And Feedline low loss foam dielectric coax RG8X or RG213 is recommended. I don't like RG8X. It's small, but in portable situations, it works great. You can pick it up at a truck stop near you for a decent price too, I might say. It already has connectors on it. And when I need a little piece of it, or even a long one, they have up to 20 feet, I think, over at Pilot now. And I'm sure there are some other places, if I don't get to Carlisle, but I understand there's a Ham that has a CB shop down there. I bet he's got them. HF coax cable, commercial ladder line, insulated ladder line. It's great stuff. Low loss, and the coaxial cable for HF, I like to use RG8, or if I happen to have it, I use some LMR 400 on HF too. Here's pictures of what the different sizes are. My story here on this monitor, but I know that shows a quarter beside them to give you a relative idea. And the ladder line, just pulled an antenna down at ran ladder line. This stuff's great to use. Headphones, when you're in an EOC with multiple radios in use, you must use headsets. Voice operation, Vox, turn it off. Use manual push to talk buttons. That's okay if you're in a quiet room by yourself at home and you don't have someone yelling from the other room at you because you're in here on the radio. But you don't have that problem but don't do it on emergency comms. A desk or a boom microphone with a foot switch is a key. To key it, the transmitter works great. Keeps your hands loose. You don't have to be looking for a microphone to push. This microphone becomes part of the radio system when I want it to be, and I have a foot switch that works for it. Desk or boom microphone, there are many different kinds. Headsets, I had a Telex headset that I used on broadcast radio, but it worked here too, but I don't like to use it so much. But Heil will gladly sell you one. They're pretty good. Battery power is critical. Match the maximum load equipment to length of time in operation and must continue before they can be recharged. I have, under my table here, I have I think that's a 700 amp hour deep cycle battery on a tender. It's lasting longer than it should have. It's probably 10 years old now. It's still going great. If you take care of them, they'll last. When the power goes down, I still have radio communications at 100 watts. I'm okay, and I can dial it back if I need to. Nickel metal hydride batteries in a handheld are great. They can store somewhat more energy than a NiCad. I don't think NiCads are even made anymore. When the rechargeable alkalines came out, I was in a situation where I needed to know the capacities of all of them, and I got to speak with an actual design engineer for batteries. And this was when nickel metal hydride was coming, but it wasn't there yet. And he said, "We're working on some cool stuff you're going to love, and you can use it in your ham radios." And he was telling me about them. And the lithium ion is a great battery. They much higher power densities, and without the memory effect of NiCads. NiCads were a great thing. They had a lot of power, but if you weren't careful and didn't run them all the way down and charge them all the way back up, they developed a so-called memory where they'd only discharge to a certain point. And there were a lot of hoops you had to go through to break that memory, and we did. We made them work. Those optional AA alkaline battery cases, I recommend them. Everybody does for MCOM accessory. Like I said earlier tonight, you can use them if you can't get your other ones charged. You don't not around them. They offer a little bit higher power than even a nickel metal hydride. They have a little more power density in them. They'll last longer. And you can tell if you look on the side of AA, compare the voltage that it says it has to what a nickel metal hydride, you're going to find that a regular AA has more voltage to it. 1.5 is compared to probably 1.2 in a nickel metal hydride. And you can get them anywhere. And it may be all you have if you can't recharge your other batteries. It's all you got to use. An external 13.8 power connection, cigarette lighter, or an external battery use is a good thing to have. AA battery cases, you can get them at different places online to go with your radio. And if you have a new enough radio, you can probably still get them from the manufacturer. I would recommend getting these things, even if you don't need them, because at some point, they're not going to make them to fit your radio. So you have to go looking for them. So there you go. External batteries, any type can be used with a handheld 12 volt to 15 volt gel cells. You can talk a long time on them with an external battery. Some battery packs are intended for power tools, camcorders. They can be used, not the 18 and 20 volt jobbers. Stay away from them, but you can find some that work. Build a DC power cable for each of your radios with suitable adapters for each battery type you might use. The ARRL has long been recommending Anderson power poles for every radio. The idea of that, I thought I had some land here, but the idea of that is every time you go somewhere, you can plug it in to their power supplies. Anderson power poles will have a discussion on those at some point coming up soon to show you how they work. And since this was done, like I mentioned earlier, these batteries that are being used in the jump start kits that'll start a big diesel truck, they're the size of an old Reader's Digest book. It's amazing what they can fit into them now. Lead acid batteries, they can spill. They're wet inside, and that's acid. You get the sealed lead acid batteries. They can operate in any position, even upside down. And the optimum charging voltage for a 12-volt lead acid battery should be about 2 volts above the battery's rated voltage, because you want the electrons to flow back into it. You're forcing them back in. Deep cycle batteries are a better choice than a common automotive battery. Like I said, I have deep cycle batteries under my bench. They were bought at Walmart, and of course they're going to tell you this one has a better warranty, and they're going to charge you more money for the better warranty. Don't worry about that. Worry about the crank or the how many amps that can deliver, and go with the highest amp one you've got. It's going to be cheaper than the most expensive one and better. They're not designed to provide constant power for prolonged periods on a regular car battery, but the deep cycles are. They're specified for uninterruptible power supplies, are a great thing to have. You find them in recreational vehicles and so forth. Sealed lead acids are in smaller sizes and somewhat lighter. Typical small case sizes are 2, 4, and 7 amp hour, but many sizes up to 100 amp hour are available. It should never be deeply discharged, a sealed lead acid. 12-volt SLA can be damaged if it's allowed to drop below 10 volts, 10.5. Excessive heat or cold can damage them too. Storage temperatures between 40 and 60 work the best for them. And battery power budgeting. Busy net control station transmitting a lot will be determining the factor of your duty cycle. Low activity stations, the receiver current will dominate, meaning lower current. The more you transmit, the more current it's going to use. This, a side note on that, this, as far as current, this one here that I have right under me now is a 650 amp one. We ran UHF radios out at the old abandoned turnpike tunnels all day long, transmitting constantly, and still had lots of reserve left. They're amazing, but they are so heavy. NiCad, nickel metal hydrides, the type of charger required depends on the battery. Universal charges can work. Rapid rate charges work. There's all kind of chargers for these things. They're saying a rapid charging can shorten the overall lifespan. I have some chargers here that'll run 14 hours to charge them. Others will do it in an hour. It depends on what I need. Sometimes the trade-off is worth the less lifetime of the battery. Lead acid batteries, always consult the battery manufacturer for the precise charging and maintenance instructions. It's best to slow charge all batteries. Automotive and deep cycle batteries can be charged with an automotive and jumper cables. You just hook them up to your car and jumper them until they charge. An automotive battery charger or a constant voltage source. And with the lead acid batteries, I'm using them in all kinds of things now. Small lead acid batteries, they must have something to maintain the charge in them or they will go bad. I have portable sound systems that we use for a lot of things. Lead acid batteries are in them. The instructions that came with them, keep them plugged in so they have that slow charge on all the time. Chargers, generators, solar powered, SLA or a gel cell must be charged slowly and carefully to avoid damage. Charging voltage must be between 13.8 and 14.5. Keep the charging level to no more than a third of its rated capacity, and the time it takes for an SLA battery to charge will be completely dependent on the amount of charge remaining in the battery. The more you run it down, the longer it's going to take to charge it up. Pretty much the same with all of them. Generators are required at all command posts and shelters for lighting, food prep, and other equipment. A radio equipment can be operated from the same or a separate generator, but must be co-located with multiple generators bonded with a common ground. Because believe me, when you're out like that and you're in the wet grass or whatever you might be in, there's going to be a voltage difference between those generators, and the grounds aren't bonded together, and I mean into the ground, into the dirt with a pole rod. Not all generators have adequate voltage regulation. Well, now they do. I mean, a voltmeter should always be part of your equipment, but the new new ones, like, well, Honda pretty much pioneered the availability of the inverter type generators, but there's a lot of people doing them. The bottom one in this picture is an inverter generator. The others are not. They all have their place, but I have several of the inverter generators. They're wonderful to have, and our club, Harrisburg Club, has one too. They can be noisy. The Honda generators are not. They're very quiet comparatively. Place a generator far away from using a heavy power cord to compensate for the distance, like a number 10 gauge power cord, not the typical 14 gauge you find everywhere. It prevents the fumes from entering the building and causing carbon monoxide poisoning when you're using a generator. High quality surge protectors, line voltage regulators, and power conditioners may protect your equipment from the defective generators. A variable voltage transformer, or a variac, can also be useful to compensate for the varying conditions. The variacs can be different sizes. They have a knob on them and a variable resistor tap that helps you compensate for it. If you don't have electricity, prevent carbon monoxide buildup. Very important. Only use a generator outdoors, far from the windows and vents. Never use a generator indoors, in garages, or in carports, and never cook inside on a charcoal or a gas grill. That's really important. Power connections, 12 amp Molex connectors are in the past. That's what the ARRL recommended. It was adequate for low power mobile radios, handhelds, and accessories. You'll still find them on a lot of radios when you buy them. They can overheat and fail when used under high power equipment and duty cycles, but a 30 amp Anderson power pole connector that I mentioned earlier, most groups now use them, and it's highly recommended. There's a standard for them, and they handle more current. They're capable of being plugged in and unplugged many hundreds of times and different times without any deterioration. What do they look like? There they are. The one on the left is an Anderson power pole. They come in two pieces, a red one and a black one. They're crimped with a special crimper and pushed together. They last a long, long time. And there's a little pin that goes between them to lock them in place. The Molex 1545 series, you'll find them on almost every radio you buy from the factory. And then at the end of the long end of it, put the Anderson power poles on there so you can plug into everybody else's power supplies when you get to a site. All power cables should be properly fused in both positive and negative leads. Fusing a negative lead does help protect the equipment from ground fault currents. That's really important. Now, vehicle cigarette lighter plug, or the PowerPoint plugs, may not deliver adequate current for a mobile FM or HF radios operating at high power. The cigarette lighter plug is a really bad connection. They just are not made for high power. It's best to have a direct connection to the vehicle battery. All of my vehicles have a 10 gauge wire coming back from the battery, fused at the battery, and then coming through the firewall or some other way with rubber grommets to the passenger compartment to an Anderson power pole connection. And then from that, you can get or create your own multiple connections that come off of one Anderson power pole. And know how much current your radio draws at different output settings. Yeah, that's good to know. This one's running a little late. This section does run long. Not all inverters are suitable for use with radios and computers of certain types of battery chargers. The best inverters are those with a true sine wave. A modified sine wave output may not operate certain small battery chargers and other waveform sensitive equipment. A high frequency conversion inverters generate significant RF noise and are not filtered. So an alternative mid-sized 12-volt computer uninterruptible power source is a good one to have. And they can be low cost, so they got a battery in them and all that. They're smaller. There are smaller square wave UPS units that are not designed for continuous duty, and larger true sine wave units are designed for continuous duty. Now, it may be a dumb place to stop, but we're only halfway through this one. There are 89 slides. I think it's time we can give it a break. It's 8:30 now, and we've been at this for quite a while. So any comments from anybody before we call it a day?
I think I'm going to need a trailer to haul all that stuff.
Yeah.
It's not going to fit in the duffel bag.
No.
Jump kit's going to be a steamer trunk.
There you go. Obviously, a lot of that stuff you can modify to your own needs, but they really go in depth in this. So it's this is one of the longer elements of this whole thing, because this is the stuff, all the stuff that you learn about regulations and all that sort of thing are great, and the operating things, but getting your machinery to work when you're out and your radios to work and all of that is important. That's why this one goes on for quite a while. But